Imagine looking up at the night sky, you see countless stars. Now picture one of those stars, a truly massive one, just disappearing. This is precisely what astronomers have witnessed in our galactic neighbor, the Andromeda Galaxy. A colossal star, known to us as M31 2014 DS1, has performed an astonishing vanishing act. It has seemingly skipped the usually violent end-of-life fireworks we expect from such giants. This event is not just a curiosity, it is a profound puzzle, challenging our understanding of the cosmos. Andromeda, or M31 as astronomers call it, is a majestic spiral galaxy. It is the closest large galaxy to our own Milky Way, a mere 2.5 million light-years away. Andromeda is a behemoth, even larger than our Milky Way, containing perhaps 1 trillion stars. For centuries we have gazed upon it, first as a fuzzy patch in the sky, and now, with powerful telescopes, as a stunning collection of stars, gas, and dust. The disappearance of M31 2014 DS1 is particularly baffling because massive stars are supposed to go out in a blaze of glory. They are expected to explode as supernovae, briefly outshining their entire galaxy. So when a star of this magnitude simply fades away, scientists sit up and take notice. What does it mean when a star just vanishes from sight? It suggests a different path to stellar death, a quieter, more mysterious route. The universe is an ever-evolving place, and this star's shocking transformation is a stark reminder that there is always more to learn, more to discover, and more to be amazed by. Most massive stars, those many times heavier than our Sun, live fast and die young. At the end of their lives, their cores run out of fuel. Gravity, the universe's ultimate sculptor, then takes over. The core collapses catastrophically. This collapse usually triggers a tremendous explosion, a supernova. For a few weeks or months, the supernova can outshine billions of ordinary stars. Supernovae are responsible for creating and distributing many of the elements essential for life, including the iron in our blood and the calcium in our bones. But what if that explosive rebound doesn't happen? What if the star tries to explode but the attempt fizzles out? This is the essence of a failed supernova. In this scenario, the star's core still collapses under its own immense gravity. However, the shockwave that should rip the star apart and create a brilliant supernova somehow stalls. The outer layers of the star, instead of being blasted into space, don't receive the memo, they simply fall inwards, following the collapsing core into oblivion. When this silent collapse occurs, the star's core continues to shrink, crushed by unimaginable forces. It becomes so dense that nothing, not even light, can escape its gravitational pull. A black hole is born. The star, in its entirety, or at least most of it, simply disappears into this newly formed singularity. This is what we believe happened to M31 2014 DS1 in the Andromeda Galaxy. Let's zoom in on the star at the center of this cosmic mystery, M31 2014 DS1. This celestial body resided in the Andromeda Galaxy, our magnificent spiral neighbor. Before its startling disappearing act, it was a truly substantial star. Astronomers estimate its initial mass was around 20 times that of our own Sun. Stars of this magnitude burn through their nuclear fuel at a ferocious rate, living lives that are bright but relatively short by cosmic standards, mere millions of years, compared to the Sun's expected lifespan of 10 billion years. The story of its demise unfolded over several years, a slow fade rather than an abrupt snuffing out. Observations showed that the star actually brightened significantly in the mid-infrared part of the spectrum back in 2014. This brightening is a crucial clue. It often indicates that a star is ejecting a shell of dust and gas, a common precursor to a supernova explosion. However, the expected spectacular optical outburst, the hallmark of a supernova, never came. Instead, the star began to fade. By 2023, when they conducted deep optical and near-infrared imaging of its location, the star was simply gone. The only lingering evidence of its dramatic transformation was the previously observed dust shell, a ghostly shroud surrounding the location of its final collapse. This sequence of events paints a clear picture of a star that tried but failed to go supernova. The direct collapse of a massive star into a black hole without the customary supernova fireworks is exceptionally rare. Most massive stars explode, scattering their enriched guts across the cosmos. This is the standard model observed countless times. So, when a star like M31 2014 DS1 quietly collapses, it captures our attention. Why are these failed supernovae so rare? It depends on specific conditions within the star's core. The primary challenge is their inherent faintness. A successful supernova is incredibly bright. A failed supernova lacks this bright outburst. Astronomers look for a star that was there and then disappears. M31 2014 DS1 is only the second confirmed instance. Section 5. Echoes in the Cosmos. N6946 BH1, a precedent. The strange case of M31 2014 DS1 in Andromeda is not entirely without precedent, though such events are incredibly scarce. Before this recent discovery, astronomers had identified another compelling candidate for a failed supernova, a star known as N6946 BH1. This star was located in a different galaxy, NGC 6946, famously nicknamed the Fireworks Galaxy, due to the unusually high number of supernovae observed within it. Ironically, it was in this very galaxy, known for its explosive displays, that a star chose a much quieter exit back in 2009. The story of N6946 BH1 bears a striking resemblance to that of M31 2014 DS1. The star, a massive one estimated to be about 25 times the mass of our Sun, was observed to brighten significantly, though not to supernova levels. Then, over the following months and years, it began to fade. By 2015, it had completely disappeared from optical view, leaving behind only a faint infrared glow, likely from dust heated by the event. Just like M31 2014 DS1, it seemed to have imploded directly into a black hole without the expected grand explosion. The discovery of N6946 BH1 was a landmark moment. It provided the first strong observational evidence that massive stars could indeed fail to explode and instead collapse silently. This earlier event helped astronomers know what to look for. It established a pattern: a star brightens modestly, perhaps sheds some material, and then vanishes. Section 6. Cosmic Detectives: How We Found the Missing Star. Uncovering the fate of M31 2014 DS1 was a remarkable piece of cosmic detective work. It required a combination of powerful telescopes, patient observation over many years, and the careful analysis of data spanning different wavelengths of light. You cannot simply point a telescope one night and declare a star has failed to go supernova. It is a process of elimination and meticulous evidence gathering. Astronomers had to prove not only that the star was gone, but also that it didn't explode in the way most massive stars do. The investigation relied heavily on long-term monitoring programs that repeatedly survey large areas of the sky. These surveys build up a historical record of celestial objects. By comparing images taken at different times, astronomers can spot changes, stars that brighten, dim, or, in this case, disappear. For M31 2014 DS1, archival data was crucial. Scientists looked back at earlier observations to establish the star's presence and brightness before its strange behavior began. This baseline was essential to confirm that something dramatic had indeed occurred. The key evidence came from a multi-wavelength approach. The initial brightening observed in 2014 was most prominent in mid-infrared light. This suggested the ejection of a dust shell, as dust warmed by the star's light glows brightly in the infrared. Section 7. Rewriting the Stellar Playbook: Implications for Evolution. The direct collapse of M31 2014 DS1 into a black hole compels us to revisit our stellar evolution playbook. Traditionally, massive stars end in supernova explosions. Failed supernovae like M31 2014 DS1 introduce a significant alternative. This challenges our understanding of supernova mechanisms. When a massive star's core collapses, it forms a proto-neutron star. This triggers a shock wave, boosted by neutrinos, ejecting the star's outer layers. In M31 2014 DS1, this mechanism failed. The shockwave wasn't energetic enough to overcome the infalling material. Understanding these failures is now critical research. Failed supernovae impact our understanding of black hole formation. Stellar mass black holes are remnants of massive stars. Quiet collapses suggest a larger black hole population than estimated. This stealth formation could explain black hole demographics, solving astrophysical puzzles. Section 8. The universe's surprises: Why these discoveries matter. Discoveries like the silent demise of M31 2014 DS1 remind us that the universe is full of surprises and mysteries. Each discovery adds a vital piece to the colossal puzzle of the universe. It pushes the boundaries of our knowledge and inspires deeper questions. This event, a star turning into a black hole without a supernova, has far-reaching significance. It impacts our theories of stellar evolution and black hole formation. Understanding these events helps us build a more complete picture of the cosmos. Section 9, Andromeda's Secrets, a continuing journey of discovery. The Andromeda Galaxy, our closest grand spiral neighbor, is a treasure trove of astronomical discovery. Its proximity and similarity to the Milky Way make it ideal for studying galactic structure and stellar populations. Even well-studied objects like Andromeda hold profound secrets waiting to be unveiled. Andromeda is an evolving system offering new insights into the universe. The discovery of a second failed supernova in Andromeda intensifies the search for more such events. Scientists are combing through data and planning new campaigns to catch these stellar disappearances. More examples will help us understand the conditions under which stars become black holes. This will refine our theories about the final stages of massive star evolution. Future telescopes will play a crucial role in this quest. Observatories like the Vera C. Rubin Observatory will detect transient events with unprecedented efficiency. These facilities will uncover more failed supernovae candidates in Andromeda and beyond. This will transform our understanding into a statistically robust sample for deeper analysis. The story of M31 2014 DS1 reminds us that the cosmos is dynamic and surprising.